Okay, so in this lesson I want to look at finding velocity and acceleration and jerk for an object moving with simple harmonic motion. So we said previously an object moving with simple harmonic motion can be described with a sine or a cosine function. So suppose I'm given that displacement is equal to a sine omega t plus alpha, where t is the time, the change in time, a, omega and alpha, these are all constants in here. So the first thing I'm going to find is an expression for velocity, and I have to know that velocity is defined as being the first derivative of displacement with respect to time. Okay, so I'm going to take the derivative of this function. So I'm taking the derivative with respect to t of this function, a sine of omega t plus alpha. That's what I'm doing. And I'm remembering, I'm just going to get rid of that and change it to a square bracket. I'm remembering here that a and omega and alpha are all constants. What's changing here is the time. And I'm taking the derivative with respect to t because that's the definition of velocity. Okay, so I can factor out this constant a and just take the derivative of the sine function. The derivative of sine function is cosine. So it's cosine blob times the derivative of blob, the inside function here. So it's going to be cosine of blob, which is omega t plus alpha, times the derivative of blob, which will be just omega. Alpha is a constant, remember. That's going to disappear. So we're getting a times omega constants times cosine of omega t plus alpha. That's an expression for the velocity of this object that's moving with simple harmonic motion and whose displacement is being described by this function. Okay? So that's my expression for velocity. I'm just going to move that over to the side here. And now I'm going to find an expression for displacement, or for acceleration, apologies, acceleration. I'm going to find an expression for acceleration. What do we know about acceleration? Well, we know that the acceleration is the derivative of velocity with respect to time. So I'm going to take the derivative of this. Again, a omega, that's a constant, so I can factor that out and just take the derivative with respect to t of this cosine part, cosine of omega t plus alpha. Okay? So what we're going to get here is a times omega. The derivative with respect to t of cosine is negative sine. So I'm going to put that negative here out the front maybe, just to keep it out of the way. So we have this times negative sine. That's going to be a negative a times omega times sine of what's inside here, omega t plus alpha, times the derivative of what's inside in here, times omega again. So what I'm getting here is negative a omega squared times sine of omega t plus alpha. Okay, one thing to note, if I factor out the omega squared, in fact factor out a negative omega squared, that's going to multiply by a sine omega t plus alpha. And that quantity inside the bracket, that function, is precisely my displacement function. So that's negative omega squared multiplied by s. So my acceleration is always negative omega squared times s. Now, useful to know, if I just think about that, look, the acceleration is a constant times the displacement, which means they're proportional, and also has the opposite sign to displacement. That's actually just my very definition of simple harmonic motion. Acceleration is proportional to its position, but in the opposite direction, with the opposite sign. Okay, so a is equal to negative omega squared times s. Notice that's a little formula in there. That's on page 54 of your formula and tables booklets. That's a really useful thing to know. It's a really useful thing to know, that a is equal to negative omega squared s. So that's going to be very helpful for problem solving. I can find the acceleration. It's always going to be the negative of this thing squared times s, the whole displacement of the function. Okay, the third thing I'm going to find is jerk. Okay, jerk is just the derivative with respect to time of acceleration. It's the third derivative of position or displacement with respect to time. So I'm taking the derivative of this function up here. I'm going to factor out my negative a omega squared because that's just a constant, and take the derivative with respect to t of the sine part. Okay, so what I'm going to get is negative a omega squared times the derivative of sine of this stuff is going to be cosine of this stuff times the derivative of this stuff, which would just be omega, since alpha is a constant. So what I'm getting there is negative a omega cubed cosine of omega t plus alpha. And if I factor out my negative omega cubed here, negative omega cubed, that's going to be times a by cosine of omega t plus alpha. And in fact, let me break that omega cubed up a little bit further. That's going to be negative omega squared multiplied by a times another omega times cosine of omega t plus alpha. And that quantity in there, a omega times cosine of omega t plus alpha, a omega times cosine of omega t plus alpha, that is actually velocity. So the jerk, which is the third derivative, is negative omega squared times the velocity. And you can probably see a kind of pattern emerging here, which you might want to explore a little bit further. The derivative of jerk is called snap, the derivative of snap is called crackle, the derivative of crackle is called pop. Okay, so practice those things. Practice taking the derivatives. This is really important. A is equal to negative omega squared s, and the jerk is equal to negative omega squared times the velocity. And the velocity can be written as a omega times cosine of omega t plus alpha. All of these things are important to make sure you know where they come from, and we look at starting to derive some of the expressions we need to know that are given in our formula and tables booklets, and coming up with a couple of other things besides. Okay, so practice that, see if you can derive those expressions yourself. Practice doing it. Come up with expressions for velocity, acceleration, for jerk, and note these things. You know, acceleration is negative omega squared times the displacement, jerk is negative omega squared times the velocity. Okay, practice.